Factors affecting reaction rates, part 3, the grand finale, the coup de grace. So there's our equation. We're using the same one as previously. And this time the factor is temperature. So increasing temp or decreasing temp. What happens there? So once again, break it down into 4 things that we want to look at. So the stress is increasing temperature, which of course corresponds to an increased amount of heat. Want to use up the heat, and I just plain said that we're going to the left. The thing is here, think of heat, like for example, think of it as, in this case, it's like a product. It's like something on the product side. I can almost think of it like an E or an F or whatever. So think of it as you're increasing something on the product side. And of course, if we're increasing heat, we can think of it, oh, I'm adding something to the product side. To use it up, I'm going to have to shift things to the left. So actually think of it as a tangible item that's present there. So shifts to the left, and as a result, of course, it's moving this way. The reactants will increase because we're forming more reactants, and products will be used up. Okay? Looking over at the opposite, if it had been decreasing heat, the temperature, that's like lowering the heat. Want to replace the heat. So once again, think of heat as a tangible item. If we removed it, such as over here, it's out of whack. We're losing product there. We need to make more products by shifting things this way. So in this case, we'll have a shift to the right, and as a result of shifting to the right, products will increase and reactants will be used up. Okay, so those are the 3 factors there. Changes in concentration, changes in pressure or volume, and changes in temperature. Okay. For the final thing in this podcast, I'd like to look at kind of an application dealing with this, an industrial application. Let's say we have an ammonia plant. We're making ammonia. And this is the reaction here. So a 1:3 ratio, 1 nitrogen molecule to every 3 hydrogen molecules makes 2 molecules of ammonia, and also as a result it's an exothermic reaction. Heat is released. So what an application, if you own this plant, of course you'd want to make as much ammonia as you possibly could. What are some things that you could do to increase their production of ammonia? And just thinking back to what we just did, what are changes in concentration, pressure or volume or temperature that you could do to basically cause things to shift that way in the direction of making more ammonia? So that's what I say here. The solution lies in determining what stresses could be placed on the system to cause a shift to the ammonia side, which is the product side. Okay, so in setting this up, kind of working backwards here. We know we want an increase in ammonia, and of course an increased ammonia means that we'd be using up some nitrogen and hydrogen, basically shifting things that way. So you kind of, it's almost like Jeopardy. Here's the answer, what's the question? So think of, I want to shift things that way. What would I have to do in order to do that? So there's quite a few different things you could do here. Possible scenarios, possible stresses, add more nitrogen. Because if you add nitrogen, the automatic response would be to use up that extra nitrogen. And if we go to the original formula here, adding more nitrogen causes it to shift to the out of balance this way. So using up nitrogen would cause a shift that way. Very similar, increasing hydrogen is the same thing. It's on the same side. If I increase hydrogen, once again I'll be out of whack, so I have to shift things that way. In terms of removing something, removing ammonia as it's formed will also cause a shift to the right. So if I remove ammonia, take it out, oh, we're too low on the product side, we have to force things that way. Just like on the farmyard, removing eggs from the chicken coop. The chickens are tricked into laying more eggs. So removing ammonia as it's formed. In terms of pressure, if we go back up to here, let's check out what we have. On this side, we have 1 nitrogen molecule and 3 hydrogen molecules, so a total of 4 gas molecules. And over on the right, we have 2 molecules of ammonia. So of course, the lower number of molecules has lower pressure than more molecules. So if we want to go to the side that has less pressure, we'd have to increase pressure. If I increase pressure or reduce the volume, there's more pressure there. It's going to want to relieve the pressure, go to the side with fewer molecules that has less pressure. And lastly, in terms of temperature, of course, heat is on the right-hand side, on the product side. So if we decrease the heat, once again, think of it as an item that you're removing. If we remove that heat from that side, it's going to be out of equilibrium. So that's going to force things to go to the product side to replace that lost heat. So let's see, there's about 5 different things. These are kind of the same one, the pressure, volume, one. So 1, 2, 3, 4, 5. 5 different things you could do in combination with each other. They'd be working with each other if you did all of them, and that would cause more ammonia to be formed. So kind of in a little industrial application dealing with Le Chatelier's principle, stresses and how those stresses are relieved.